Hi everybody, and welcome to another session on Speed Maths. You'll recall in the previous session we had covered a method where we could multiply a two-digit number with 99. So for example, if I were to multiply a given number, let's say 88 with 99, this is what I was required to do. I would simply write a number less, which is 87. In all cases, one number less. For the second half of the answer, this is what I was required to do: 100 minus 88, which is basically 12, and I write the 12 over here, and that becomes my complete answer, 8712. Well, in today's session we'll be more of extending this method, the difference being that now we'll be using 3 nines or 4 nines, or for that matter any number of nines. Okay, first of all we'll use a method to find out 999 times 458. The small condition being that since I have 3 nines over here, I can use a max of a 3-digit number. Therefore, I cannot use a number which has got more than 3 digits in this method. So what do? Well, I'm going to basically copy this. I'll be writing 457. So far so good. The only difference being that here I was deducting the number from 100. And why so? That was because there were 2 nines, and I was using a number 100 because there were 2 zeros in it and it's the closest base. In this case, for me the closest base would be 1000, and 1000, as you can see, has got 3 digits, 3 zeros. Therefore 458 to be deducted from 1000. Now this itself may take a little time, so what we do is we simply put a rule. We'll say the last digit is to be deducted. This 8 is to be deducted from 10. So the last digit deducted from 10 gives me 2. All the remaining digits to be deducted from 9. So this will be 5 and 4. Let me write it out clearly. That's 457 542. That's your answer. Let's take up another example. 999 times 687. What do we do right first? The first half is always easy. That's 686. That's 1 less than the given number. For the remaining part, all the digits from 9 and the last from 10. 9 less 6 is 3. 9 less 8 is 1. 10 less 7 is 3. And that is my answer. Let's take up another larger number. Let's say 9999 to be multiplied with 4587. Nothing, I tell you, nothing changes. I'll simply copy the previous method. I'll first write a number which is 1 less. That's 4586. Okay, now here I've got 4 nines, so I'll choose a base 10,000, which has got 4 zeros. Don't take the pain to deduct the actual number. All you do is the last digit from 10 and the remaining from 9. So this will be from 9. That gives me 5. This will be from 9. That gives me 4. This from 9 gives me 1. And this from 10 gives me 3. And that is the complete answer, 4586 5413. Let's take one last look at the method before we wind up. Let's say I have a number. I've got 3 nines, so the condition is I can use a max of 3-digit number. Now I said max, that means you can actually use a 2-digit number. Let's see how I can multiply 28 with 999. Well, what we do is we treat 28 just the way we treat a 3-digit number. The only difference is I'll put a 0 over here to make it look like a 3-digit number without changing its value. What do I do first? Well, 1 less than this, 27. You'll realize the 0 before doesn't count, so I don't need to write this over here. The second half is all digits from 9, the last from 10. This from 9. 9 less 0 is 9. 9 less 2 is 7. And this is to be deducted from 10. 10 minus 8 is 2. So this is your complete answer. Okay. So the condition here was that if I've got 5 nines over here, I could use a max of a 5-digit number. In the next session, we'll come up with a method which basically removes this restriction, which means that if I had only 2 9s, I could still multiply it with a 3 or 4 or a 5-digit number. But for that, let's meet up in the next session. Meanwhile, thank you for being with us.